Hello, welcome viewers. Hope you have gone through my previous lectures. As I already repeated in several of my uh, lecture series, that these things are sequentially made. Therefore, I would expect you to go through all my earlier lectures. That's why I'm numbering the lectures. This is Kinematics number 16. Kinematics number 16. Now, so far, if you see, I have already told you kinematics in general. Kinematics we looked at in 1D motion and 2D motion. Analytically we did it, and we went into a specific case of projectiles. Now I am extending that. Then we were looking at the relative motion in 1D as well as in 2D. Now I want to go back to that your kinematics in 2D motion. I now specifically go into a special case called circular motion. It's very, very important, my dear friends. You have got to understand the concept very clearly. So I go from the most fundamental or right from the scratch so that you'll have no doubt at all when you hear of certain parameters or the certain things, how they have come up, etc. Now, let a particle move in a circular path of radius r. Now here with center, I have taken one coordinate system. This is x-axis, this is y-axis, this is z-axis. See, away from the plane is z-axis. All three are required for us, I will tell you. And first I took some general, the particle is here, making an angle theta with x-axis. So I resolve this into two components. I'm only looking at kinematics. Remember, there are dynamics also come into picture, but not at this stage. Okay? So if I resolve this into components, this is cos theta, this is sine theta, therefore I have what is cos theta and sine theta. You can very clearly see that this is cos theta part, this is sine theta part. Okay? Now, here, theta is called your angular displacement. Okay? Therefore, I'll write it here. Theta is angular displacement or position. Therefore, omega is d theta by dt. Angular acceleration is d omega by dt. This is generally given in radians. This is in radian per second. This is in radian per second square. You can draw similarities between linear motion and circular motion. I will tell you one by one in due course, but every point you should be very, very specific while drawing all this. So, we defined theta, we defined omega, we defined alpha. Therefore, what do? Here I and j are fixed axes. Okay? If that is the case, I know that rate of change of position is dr by dt. Now if I define I constant, r of course is anyway constant, or in both the cases I took out, I cos theta is minus sine theta d theta by dt. I think I'll write it here. D by dt of cos theta is minus sine theta, then theta derivative d theta by dt, or I can write this as d by dt of cos theta is minus omega sine theta. Similarly, d by dt of sine theta is cos theta d theta by dt. This is omega cos theta. A standard thing that we will be using everywhere. So be careful about this. So cos theta. I cos theta means what do I write? Minus I omega sin theta plus j sin theta, that is j omega cos theta. Look at that. Now I have derived this velocity. How is velocity here? This is your tangential to the circular path. This I am sure you are aware. Now if I want to resolve this into components, this is minus I, this is plus j. And if this is theta, this is theta, therefore that is theta. So V, if I want to resolve, how do I get? V cos theta minus I, V sin theta plus j. Okay? If I resolve that, I write this as omega is common, r omega minus I sin theta plus j cos theta. Now, if you resolve this V, how are you able to write? I V sin theta minus I, see V cos theta like this, and this is V sin theta minus I V sin theta plus J V cos theta. V is magnitude, okay? Now this V is common. How am I writing this? Look, so by analogy, your mod V is R omega. One very important point you should understand is, see, theta. Take for example, theta. What is the direction of theta? Initially, people used to say clockwise or anti-clockwise, etc. Now that's gone. All angular variables are directed perpendicular to the plane. A very, very standard thing that you should remember. All angular variables are perpendicular to the plane of motion. This is important for you. You may take theta, omega, alpha, all are perpendicular to the plane of motion. Which one is in the plane? Which one is perpendicular to the plane? Everything we are going to see now. You see, R and V, you can see are perpendicular. This is R, okay? I am extending. V I am writing here. Now, you can see, V and R are perpendicular. How do you know that they are perpendicular? From the diagram you can say R, V, and this, if you take dot product of this, it should be equal to 0. What dot product? V bar dot R bar is 0. How? I cos theta, I sin theta minus. So, minus cos theta sin theta plus cos theta sin theta, it is 0. Remember. So, V dot R is 0. Now, question is, how to express V vectorially, because this is Ij in terms of R and omega. Okay? First, I think you got this. I will erase this. Now this V bar, what is omega? I told you omega bar is equal to omega k. Omega bar is omega k. R bar is R into I cos theta plus j sin theta. I am now looking at a vector that is perpendicular. Omega I is like this, R is like this. How these two, product of these two, it should be either omega cross R or R cross omega. Omega dot R is bound to be 0. K dot I 0, K dot J 0. You know very well. So it should be either omega cross R or R cross omega. If it is omega cross R, K cross I, what are you getting? J plus J. Where is that? Yes, plus J, you are getting cos theta. K cross J minus I sin theta. That means V bar now can be written as omega, not R cross omega. Omega cross R bar. V bar is equal to omega cross R bar. Here I will write it at some point. V bar is omega cross R bar. Okay? Now what is mod V? We have already seen. Mod V is always R omega or omega R. Okay? Fine. So far so good. Now I want to look at acceleration is dv bar by dt. dv bar by dt. Now this term I am erasing to make room for that. So R omega minus I sin theta plus j cos. There are two terms which are variables. Use a product formula. A is equal to d by dt of all this. So R is common. I will first write d omega by dt into minus I sin theta plus j cos theta. Right? R common plus omega into d by dt of minus I sin theta plus j cos theta. Carefully follow what I am doing. I am using product formula. This is variable, this is another variable. So first I took derivative of this, multiplied by this, then omega times derivative of this I have multiplied. Each one we have to work out separately. Okay? But we know what is d omega by dt. We have defined already alpha. Is it clear? It is alpha. Therefore, I will write here R as usual, alpha. This is minus I sin theta plus. Now this is omega. Now as before, d by dt of sin theta. Minus sign is there anyway. That is cos theta d theta by dt. We already did it before. So d theta by dt is omega. So sin theta derivative with respect to time is cos theta omega. Minus I as usual. Sin theta is omega cos theta. Similarly, plus j cos theta is minus sin theta omega. I hope you are able to follow this. Sin theta derivative is cos theta omega. Cos theta derivative minus sin theta omega. I have put it a little while ago. You can go through that part. Now, you look, this omega common here, it becomes omega square. Okay? Now, We will try to rewrite this in a form that is useful to us. And this part, of course, we have already done that here. Now, you can very clearly see, if I take R inside, I'll take it as R alpha minus I sine theta plus j cos theta and R omega square. There is a negative sign, common, isn't it? Here also, here also. Therefore, minus I cos theta plus j sin theta. It's wonderful, very interesting. If you see, I can omega square R into I cos theta plus j sin theta is R bar. You already see that. And here R alpha, and this is minus I sin theta plus j cos theta. What is the direction of mine? We have already seen minus I sin theta plus j cos theta is the direction of our linear velocity, isn't it? So V cap is equal to minus I sin theta plus j cos theta. That means the direction of R alpha is either along V bar or opposite to V bar. That is one important point. I'll come to that. But before that, just as we have seen, alpha bar is equal to alpha k, okay? And R bar is equal to R I cos theta plus j sin theta. Now, as before, if you take cross product, only two possibilities, either R cross alpha or alpha cross R. So, alpha cross R means k cross I, j, and j cos theta you are getting, and k cross j minus sin theta I. So, it is again, I can write it as alpha cross R bar. Now, this is minus omega square R bar. Now, there is another issue here also. I may not explain it to you here, but I will write down minus omega cross R. Omega cross R. Remember, this is a very, very important result. What is the direction of the second term? And what is the direction of the first term? Remember, this is a linear acceleration in the plane. Acceleration in the plane. So, the acceleration of a particle in circular motion consists of two parts. One is this, which is tangential to the velocity. What will be tangential to the velocity? Either along the velocity or opposite to the velocity. And this one, what is the direction of this? R bar, minus R bar. How is R bar directed? Away from the center, we have seen. I will show it to you here. This is R bar. Minus R bar means towards the center. Okay? So this is towards the center. Two things you are getting. One is tangential and other is radial. But how to say it is towards the center? That is called centripetal. I'll write it again here. First of all, now I erase all this. I'm no longer interested in this. I will write here A bar is equal to alpha bar cross R bar minus R bar omega square. I have written it over there. So the first term is called tangential component. The second term is called radial component. Both are perpendicular to each other. AT bar is perpendicular to A bar. So what is the role of AT bar? What is the role of AR bar? It needs some discussion here. We will look at their significance. Then you will appreciate this much better. I will write it here. R bar, V bar, AR bar. Now this may be AT bar, this may be AT bar. Any one of these two. Why? It is along the tangent. Along a straight line means two possible directions. One is along velocity, in which case magnitude of velocity increases. The other case is magnitude of velocity decreases. Be careful about this point. What is the role of the first term? First term always changes only the magnitude of velocity. First term always changes only the magnitude of velocity. So, I take that as tangential acceleration, and AT, if I write d by dt of mod v, if I am writing. So, the rate of change of magnitude of velocity is called tangential acceleration. If you recall, in all our 1D motions we use this only without putting the subscript t. I think I did mention this point at that point of time. So I want you to take note of this very seriously. When a particle is in circular motion, now do not get confused by the word rotatory motion. I will discuss that later on. As of now, we will focus only on circular motion. Okay? Now, the circular motion we saw, we got two terms. First term is exclusively due to change in magnitude of velocity. If mod v increases, AT is positive. If mod v decreases, AT is negative. Okay? If mod v is constant, AT is 0. And what is AT? We have just written. Order is important here. Never write R cross alpha. Alpha cross R. What about the magnitude of AT? R alpha. So if AT is 0, alpha is 0. Therefore, angular acceleration is exclusively related to tangential acceleration only. In other words, just because there is a circular motion, alpha need not be present. Okay? Alpha need not be present. When will it be present? When AT means your modulus of velocity say changes. For example, 30, 40, 50, 60 or 40, 30, 20, 10 likewise. So if it changes, we have seen at greater than 0 means what? Along velocity, along v bar. This is opposite to v bar, this one. Increases means that is along v bar. That is very simple, straightforward thing. So no issue at all. Okay? Now come to the second important point. What is that? Minus r bar omega square. How is it that minus r bar is towards the center? So minus r bar omega square is towards the center. Okay? And this is, as I said, is called radial acceleration, or because this is, whether it is clockwise or anti-clockwise, centripetal is always directed towards the center. This is important. Centripetal means center seeking. Okay, I am not saying why is this due to. If I discuss that, I am getting into dynamics. I am not getting into the dynamics at this stage. Okay, now what is it that we have learned? We will see now. AR is minus r bar omega square directed towards the center. AT bar is alpha cross r. It's directed either along v bar or opposite to v bar. Another very important is AR bar is perpendicular to AT bar. You know, to confuse you, they keep on asking you, what is AR dot AT? This is bound to be 0. So, the acceleration in a plane of motion consists of two parts generally. One is tangential acceleration, other is radial acceleration. And this radial acceleration is essentially due to change in direction of velocity. Change in direction of velocity. So, AR is due to change in direction of velocity. Okay? Now, with this background, if I discuss uniform circular motion, means alpha 0, then AT 0, because mod V is constant. Direction changes. Don't say velocity is constant. Mod V is constant and omega bar is constant. And constant uniform circular motion means I am telling you what wrong. Mod R is constant. Mod V constant. Alpha 0. AT 0. And mod AR is constant, but AR is present. So, what is the essential condition for circular motion? Maybe I can say, what is the essential condition for curvilinear motion? whether magnitude of velocity changes or not, AT may be present or not, it makes no difference. But if radial acceleration is present, then it is curvilinear motion. If a body is simply going like this, why should it take a turn? That something is pushing it towards itself. I am not getting into the cause of motion, I have already told you. I am not getting into that. I am only looking at the observed feature. It's a purely analytical expression I derived. I got all these points. Therefore, I am able to discuss with you very clearly. Is this clear to you, my dear friends? What is essential for circular motion? For circular motion, radial acceleration is a must, or centripetal acceleration is a must, without which the curvilinear motion is ruled out. This is what you have to do. Yeah, AT may be present, may not be present. I will show you now. I will give you, for example, this is a motion. Maybe 5 meters per second, 10 meters per second, 50. What is happening here? Curvilinear motion. Therefore, at any point if I take, this is AR, perpendicular to V bar is it. What is happening to the magnitude? Increasing. If it increases, AT is along the velocity. So this is AT. If this is AT, this is AR. This is your A bar. This A bar is called total acceleration, or simply acceleration, nothing else. Okay? Now you can see A bar, what angle does it make with V bar? Acute angle. Okay? So, in this case, theta is less. Theta, what is theta? Angle between A bar total and V bar velocity. Now the same thing I take. What's the difference between the two? Both are curvilinear motions, but this is magnitude is decreasing. It makes no difference whatsoever to this. Therefore, it is AR directed towards the center. But V is decreasing. Therefore, AT is directed opposite to V bar. What is the total acceleration? AR bar, AT bar are the two components of A bar. Now, what is the angle between velocity and total acceleration? This is obtuse. The moment they say obtuse or acute, you can immediately interpret and then come out with the answer as to what type of motion prevails. Say, for example, acute angle you are taking. Acute angle means immediately, yes, this is a curvilinear motion and the magnitude of velocity is increasing. Take the example of a scooter. A fellow who is new to the driving, when he takes a curve, he gets excited and starts raising his accelerator. Suppose he goes on, then what is happening? As he takes a turn, magnitude of velocity increasing. So that is this case, right? So speed increases and it is a curvilinear motion. What about this case? A prudent fellow, while taking a turn, he reduces his velocity and takes a turn. Why and all that we will see, because we know in reality one would skid there. Why it happens, we will see later on. So, obtuse angle means magnitude of velocity goes on decreasing. That is number one. And number 2, it is a curvilinear motion. Okay? Acute angle we saw, obtuse angle we saw. Supposing if I want to have exactly pi by 2. What do you mean exactly pi by 2? The magnitude does not increase. Therefore, AR is like this. This itself is A bar because AT is 0. What is the angle between them? Pi by 2. If A bar and A bar is perpendicular to A bar, then it is a uniform circular motion. Total acceleration I am referring to. So you should understand this. Now on the other hand, what are the other possibilities? 0 or 180. Acute I have seen, obtuse I have seen, 90 I have seen. Therefore, 0 or pi correspond to 1D motion. I hope it is clear to you now. Circular motion, once I am done with this, we are able to get all these interpretations. Okay?